So we're going to discuss in a little bit more detail what the game loop actually does. And to do this, we're going to break down the two major commands of the game loop, which are update and draw. Update, of course, is the heart of the game loop, and most of the work in every video game stems from the update command. So it's either exists right directly in the update command, or it's in other commands that are executed from the update command. And there's a few set of operations that occur without fail in the update section. There are others that some games don't have to apply to. So for example, in a game of tic-tac-toe, I don't need to do collision detection too much or any physics or anything like that, unless of course I'm adding extra stuff into the basics of the game itself. So the first thing that happens in update is the game will check for input. Now this is input from the user typically, but it could be network traffic if you're making like a network game or anything like that. But from the user, typically we're going to be looking at either keyboard, mouse, game controller, that kind of stuff. And if input is found, then what will happen is the game will trigger another action. So that other action might be like a jump command or something like that, or triggering an animation to start or even stop, depending on what's actually going on. So that's the first thing that's going to happen, is checking for input. The next thing that we're going to do is we're going to start updating the game elements. So updating the game data. Update game data. And there's a few pieces to this. So I'm just going to create a couple of little subpoints here. So it might be things like updating locations. So locations of game elements like players, bullets, and things like that. Beyond the update of the locations, animations. Remember, animations are just a sequence of frames, a sequence of pictures. So every update in the game loop, we tell it to go to the next frame. And that next frame will then be drawn on there. Or it might end the animation depending on the type of animation it is. Then we get into the physics. So once things have been moved, if they have certain things like an acceleration or gravity or whatnot, this is then applied to those moving elements. And once you have the physics applied, then you got to see, hey, did you hit anything? So we do collision detection. Oops. So the collision detection will check to see whether any two elements collide, and then based on this there might be some other resulting action, maybe an explosion, or maybe something bouncing off, or maybe they're just ignored completely. Not everything needs to collide with everything else. So for example, you don't need your bullets or whatnot colliding with your score that's drawn at the top of the page. That doesn't really make a lot of sense, unless of course you're building that into the game. And then we talk about other things like in-game data changes. So data changes. And this might be things like scores. So like scores, health bar, stuff like that. But you may also see other things such as like the state of the game, so game state. So maybe the user typed the pause button, so the game needs to change to a pause state, so it stops animating and everything like that, and the game kind of halts for now. And then you want to play any sound effects. Play sound effects. Now it's just going to trigger them, and then the sound effect will be played. Hopefully, because the game loop operates so fast, you won't notice any hesitation between the action and then the actual sound that occurs. Again, not all games need to use all of these update operations. But once we have all of that data updated, it's now the draw's turn. And the draw is basically going to look at this information that we just changed and draw the current state of affairs. And it does this in layers. Think of it like a cake. Okay, it does the first layer at the bottom. So the first layer we're going to see are things like background images. So this might be like the sky, things like that. Oops. Can't really write well today. After the background images, we have our middle ground images. And now this is typically where your character is. So your characters, your enemies, all the main storyline type things. And then of course we have our foreground. A foreground is typically made up of environment elements just to give the idea or the illusion of depth. So you might have like a bush or something like that pass in front of the player, and that'll give the illusion that the player is actually behind that bush. So if we draw it in this order, background, middle ground, foreground, we don't even have to do any work because the game itself will draw it after. So it will show like the character is physically behind the foreground. And then finally, we got to inform the user. So we draw our heads-up display. Most times this is typically shortened down to HUD. And this is might be made up of things like scores, maybe targeting reticle, or anything else that usually is sitting on there like a mini map or something like that to inform the user of what's going on in the game itself. So this is the idea of update and draw, and again it just creates an endless cycle. So update leads into draw, which then flows back into update, and we create this loop, 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 loop. And your game loop is just made up of these two operations over and over and over again, roughly 60 frames per second, roughly 60 times per second. Update then draw, update then draw. So that is the basics of our game loop, and we're going to look into actually doing it within our programming language next.